concept of climate change and sustainability is becoming important in the world every time. And to achieve sustainable and environmentally friendly future for the wood industry, effective measures must be taken through sustainable forestry and efficiency during the processing of wood. Product manufacturing should be done from sustainable sources of raw materials. And as we all know, eucalyptus wood has many uses, but most commonly it is used for pulp and paper production as a source of short fiber. Agroforestry has been recognized by Kyoto Protocol as a greenhouse mitigation strategy, and we know for sure it is rich, eucalyptus is rich for carbon sequestration, whereby agroforestry system creates synergies between adaptation and mitigation actions. This study, which was done through my student in Thailand at master's level, provides an estimate for carbon sequestration potential of eucalyptus, which is grown in the rice agroforestry system in Thailand. The overall objective of the study was to establish potential for climate-compatible fiber sourcing from Eucalyptus-Rice agroforestry system in Mburu province of central Thailand. And the specific objectives were to determine the fixed carbon content from the eucalyptus wood by analyzing the proximate and ultimate composition and compare to plantation-grown hardwoods. And two, we were to determine the carbon sequestration potential of the studied agroforestry system by estimating carbon dioxide emissions from transportation of the raw materials from the source to up to the gate where the pulp mill was situated. The scope of this study was to provide an estimate of carbon sequestration potential of the Eucalyptus-Rice agroforestry system. The study focused on carbon dioxide emissions associated with the transportation of the raw material to the gate of the mill, and then further analysis on the proximate and ultimate composition of eucalyptus wood was conducted to determine the fixed carbon content. In Thailand, the eucalypt planting in agroforestry system is due to growing pulp and paper industry. So as a source of short fiber is a requirement that we must improve the source of this short fiber. These trees are planted on the embankment of the rice paddies, cassava and corn crops. Planting of eucalyptus needs small investment and minimal workforce. This generates constant yield and regular income for the local farmers. And the agroforestry system can mitigate greenhouse effects, maintain ecosystem health and biodiversity, and long-term provide food security and reduce poverty amongst the communities. It also has the potential to improve the soil fertility and increase biodiversity of degraded land. The photo shows the areas where these eucalypts are planted between the rice or the fields of the plantations of these corn crops. In contribution to the climate change, the greenhouse gases which are released and trapped in the atmosphere cause global warming and a big concern to every one of us. And we all know that forests play an important role in global carbon cycle, both as carbon sinks and pulls through afforestation, deforestation, and in the bad situation, deforestation. The carbon in the forest ecosystem and carbon contained in wood products, that is paper, need to be accounted for. And for effective carbon sequestration, one only can be considered if there is positive net carbon balance from an initial stock. We must account for what we assume has been contained in our wood. And in agroforestry system, carbon sequestration is dynamic and can be divided into 3 levels. The first level is at the establishment, where many systems are likely to be sources of greenhouse gases and carbon, nitrogen from the vegetation. Then that one is followed by accumulation phase, where tons of carbon are stored in the bolls and stems of the trees in the soil. And at the end of it, we have the rotational period when the trees are harvested and the carbon is released back to the atmosphere. In this situation, the forest biomass as used by forest sector affects only a small part of the carbon cycle. The methods that were followed. The study was conducted at Gichuhi province, where this farming is done. That is the map, and that's how the fields are likely to be situated. Then the selection of the samples were done for stems aged between 3 and 3.5 years. The spacing was 1.5 by 1.5. The average diameter at breast height, 8.3 centimeters. Average height was around 6.3. Trees were felled by use of a chainsaw, leaving a stump of about 15 centimeters from the ground. This would allow for coppicing, growing back of these stems. Proximate analysis, we followed TAPI standard, where a mini mill was used to give us powder. The moisture level was determined at 105 degrees Celsius. Volatile matter was determined at 950 degrees Celsius in a mouth of furnace for 3 minutes. And ash content was determined in the mouth of furnace again at 750 degrees, where we dried to constant weight. Simple procedure. The first photo, we have the mill, then we get the powder, we dry it in the furnace, and the last one, we weigh the end product. The ultimate analysis was to determine the elemental composition of carbon, hydrogen, nitrogen, and oxygen in the eucalyptus wood. CHON analyzer was used by Parkin and Elmer, that series. This analyzer used gaseous products freed by pyrolysis in high purity oxygen. After combustion, separation is done, identify and quantify the resultant gases. The combustion gases, that is CO2, water, nitrogen, and sulfur dioxide, are then transferred in the chromatographic column for separation. In short, that equipment is automated and it gives direct results. So functional unit and boundary assessment, here we estimated the weight of standing stem to around 60 kgs as delivered to the mill. That figure gives us the source of CO2 and oxygen in the lead situation. The transportation was done by trucks, 2 levels of transportation, where the long trucks C and G, these were using compressed natural gas, where the carrying capacity was at 32 tons. They covered 367 kilometers. While empty, these trucks were consuming 80% of the fuel, and that conversion is done. And then at the second level, smaller trucks were used. They were carrying 7 tons of this wood for a short distance, where the correction was done to the mill. By sketch, that is how the field is. The smallest circle on the left here, these are the local farmers. They transport the wood 20 kilometers to the distribution center, and from there we use the big trucks to take to the mill. Results and discussion. Weight distribution from the stump, trunk, and crown. We got an average of 36, 65, and 3.9 respectively, but after debacking, the average weight of tree was put at 60 kgs. On average, was put at 60 kgs. From the approximate analysis, the moisture, volatile matter, and ash, we realized that this eucalyptus wood had low ash content, high volatile matter, and from literature it has been reported that these are an important factor, especially in chemical recovery during the pulping process, to solubilize during the separation of lignin and cellulose. So these are good qualities for pulping. On ultimate composition, carbon, hydrogen, nitrogen, and oxygen, the carbon content of the eucalyptus trunk was realized to be at 46.58 on dry weight basis, and this information allows for evaluation of balance of the fixed carbon content in the eucalyptus wood. Determination of fixed carbon content refers to the calculated value of the difference between 100 and the sum of the moisture, ash, and volatile matter. And from my computation, the fixed carbon content came down to 16.21. The fixed carbon content of this wood for pulp production, which is planted around the rice paddy field, came down to 16.21, which is very close to other results that have been reported by other authors. For example, Eucalyptus Bethame, which observed very close to that, which came to around 16.3% of the fixed carbon. And therefore, the studied eucalypt wood reported high fixed carbon content, low ash content, and high volatile matter. This demonstrates suitability of this system in carbon storage. Here in this table, we were estimating the CO2 that was produced during transportation by use of these compressed natural gas trucks. the fuel consumption was computed, and total to and fro from the point of correction to the mill, we realized that it was consuming around 11.74 kgs of this of compressed natural gas per trip when it's empty, 183.5 of this gas when it's fully loaded. And when we divide that by the tonnage of what is transported, comes down to 0.037 kgs of this compressed natural gas per kg of log when it's empty. 0.015 kg of CO2 is produced from this after computing the emission by using US EPA emission factor on this compressed natural gas to know how much of this CO2 is produced when we have the fuel consumed by the truck. So effectively the total CO2 generated down there, we realize that 0.026 kgs of CO2 per kg of log is what was recorded as generated from our system. And the overall generation must include extra 19%, and after computing, we get 0.031 kgs of CO2 per kg of log that is transported to the mill. From the smaller trucks, I'll go straight to the final conversion, which came down to 0.051 kgs of CO2 per kg of transported log. And the overall generation of DSO trucks, the small ones, has to include 28% extra, and in effect gives us 0.065 kgs of CO2 per kg of log, and therefore the total emission includes the long distance and the short distance, comes to 0.0375 kgs of CO2 per kg of log. And the gross CO2 uptake is gotten by subtracting the CO2 emission from the transport process from the photosynthetic activity. It comes down to 6.65 conversion per kg of what we have is 1.012 kg of CO2. Convert all that to pounds, gives us 0.608 pounds of CO2 stored per kg of wood. Sorry, I'm rushing. And that one converted to the whole acreage of what is grown in the field, we get that it is possible to multiply by 596,807 stems, and it gives us 23.67 metric tons of CO2 equivalent per hectare. And in effect, we confirm that all what happens in those fields has the resultant effect of increased household income, increased land use activity, minimal investment and workforce, no effect on the crop productivity, resilience to climate fluctuations, and local knowledge, social and cultural values. Of course, same wood can be used for furniture and other construction. And in conclusion, eucalyptus tree that is grown around the rice and those crops has the effect of sinking carbon and can be used as a raw material for paper making. It has shown fixed carbon content of 16.21 with very high contents of volatile matter and low ash content. The eucalyptus rice-based agroforestry system can sequester an estimate of 6.698 times 10 power negative 2 metric tons of CO2 equivalent per average tree after 3 years. And therefore, planting eucalyptus tree for pulp production in agroforestry system around the rice is therefore compatible with climate development without compromising the quality of the wood, especially for paper making. I thank you all.